All right, welcome ladies and gentlemen to week 3 open Q&A. My name is Brian McLogan and I'm excited to do another Q&A for you. I do have just about 7 questions that I'm going to cover for this kind of open Q&A. So I do apologize. I did see that in my last community post, a lot of people added in some questions. And I know once I go live, there's already been some people that have been kind of here early, as well as people that kind of get, once we get through this live stream, they're always adding the questions. And I'm just not going to be able to get to them, even though I do not have school tomorrow though, but I have a lot of stuff that I need to start preparing for, especially for my next chapter, but at least in my class, getting everything prepped. So I have a lot of my notes, but I need to get everything ready to go. So I do have some good questions though. We're going to cover, let's see, the rules of exponents, especially with negative exponents. We're going to do another completing the square problem. So identifying the vertex by completing the square. We're going to look at applying the quadratic formula. I believe my calculator has battery, so I can complete this problem, and I do. So we'll go ahead and go through that. We're going to learn how to write the equation of a line given the slope and through a point using the point-slope form. We're going to solve some equations using some rational exponents. And then we're going to find the point. We're going to go ahead and find the point of a parallelogram given A, B, and C. And I believe there was one more. Yes. And then last one is a kind of polynomial division one. So P of X is divided by X minus 2 Q of X. So Q of X is the quotient, and then we have a remainder, and what we want to do is be able to find P of X. So again, guys, you know, typically I try to get this roughly between 30 and 45 minutes, and typically anywhere from 5 to 8 questions is going to do that. So we'll kind of see how the live stream goes. You know, I always recommend, guys, if you do have a question, please post them in the chat. You know, people are always commenting away and giving people advice, or maybe giving them a link to a video, maybe something I've done or somebody else has done. So if you do have some questions, feel free to add them into the chat. And hopefully if anybody has some advice for you or some ways to kind of help you solve your problem, you know, feel free to let those people know. So I do want to welcome, let's see, we have Ella, Jittery, Araf, Adeline. Good to see you guys back in there. TNS Lover, good to see you back again. Siddharth, awesome. And then a lot of things. I don't know why my fonts everything is so small, but it's kind of like hard to read everything with the lights and my camera over there. So, but either way, hopefully you guys are having a good start to the new year and to the new decade, and getting ready into your math class. Yeah, as we get into this now, the second stretch, at least for my class. Currently right now in pre-calculus, we are wrapping up our chapter on analytic trigonometry, and then we'll be getting into applications of trig. So what did I see? Well, thank you very much. Can you go over graphing sine of x? Oh, actually, Brian McLogan, yes, whoever Brian McLogan is. But yes, actually, there was actually a chat on there that I actually meant to write over there. And I'm not sure if this is who that was. But yeah, actually, I did receive I was going to go over, let's see, y equals, let's see, what did they want me to do? What was that problem they had? I think they gave me y equals 3 sine of x. Let's do a y equals sine of 2x. And then I can't remember what else they did, but let's just do one like this. Y equals sine of x minus pi halves plus 1. So we'll do something like that. Hopefully just kind of seeing all those transformations, so therefore you can kind of apply them to different things. So Wendigo, Firemaster, Naja, Kevin, Catherine, good to see you guys. Thank you so much for joining in on the live stream. Let's go ahead and get started, guys, because if I do have some questions, I would love to be able to get into it. And thank you, my lovely wife, for adding into my live stream. All right. So here we go. Week number 3, Q&A, simplify. So the student just asked me to talk about simplifying with negative exponents. And so therefore I made up this problem. And I just wanted to kind of like review a couple things. And obviously I could spend a lot more time explaining a lot of this, but just try to keep things, you know, kind of short just remember when we have a negative exponent, for instance, like negative a, then that is going to represent basically that as a reciprocal or in the denominator. So if we have x to the negative a, that is going to be equivalent to 1 over x to the positive a. And on the same stroke, if I have 1 over x to the negative a, then I can rewrite that as x to the positive a. So if we have a rational expression and we want to simplify, we could use the rules of exponents just as they are with negative numbers. Typically, students are going to make mistakes when they're dealing with negative numbers. And if you recall, if I had like x to the a over x to the b, that's equal to x to the a minus b, right? That good old rule of exponents. But typically what I tell my students when they're doing a problem like this is, to avoid making some of those errors, just to rewrite everything as a positive exponent. So if you have a negative exponent in the numerator, you're going to write it as a positive exponent in the denominator. And if you have a negative exponent in the denominator, you're going to write it as a positive exponent in the numerator. So let's just go ahead and write these all positive and negative here as they are. So therefore, let's see, the x is going to go in the denominator. So let's write this down. So that becomes an x squared. X to the 0 is not negative or positive, so we'll just keep that there. We'll talk about that in a second. We can put y to the 5th up here now. The y to the 3rd can go down those. Those are like swap. And then we have z squared up here, and then we have just a z. So remember, technically, this is like z to the 1. If you don't have a number there, then we already have something for 0, so we'll write this as z to the 1. And I don't know why. Yeah, okay. So now we can apply the rules of exponents, okay? Now notice there's no x's in the denominator, in the numerator, so therefore we're just going to have x squared, because remember x to the 0 is going to equal 1. So 1 times x squared is just going to be x squared. I do have to stop because I do got another super chat, so I do very appreciate it. Doesn't have to add in with a question. But Grande Blanco, thank you very much for your super chat. I really do appreciate it. Thank you so much. I really do. And so we have x squared, and then we have in the denominator here, I have y cubed. In the numerator, I have y to the 5th. So when I subtract them, 5 minus 3 is going to be y squared. That's positive, so that's going to remain in the numerator. And then up here in the numerator up here, I have z squared times z to the 1st. Why did I put 2 of them up there? There we go. That negative 2 goes up, right? So it's z to the 1st times z squared, which is going to give me az cubed. Now again, these exponents do not have the same basis, so there's nothing else really we can do from there. We'll just leave the problem as is. All right, the next one is identify the vertex via completing the square. So the obvious way would just take the b divided by 2 squared. But most students forget that. They don't understand why it comes from. And typically we would go through a whole lesson explaining that process. So what I'm going to do is I'm going to say, what if the problem looked like this? Y equals x squared plus 8x plus 16. And what if I said find the vertex here? Well, hopefully you'd recognize that if we want to find the vertex, then if we had it in vertex form, x minus h squared plus k, then the vertex would be h comma k, right? So if I could rewrite this as a binomial squared, right, and factor this, and actually this is factorable, into x plus 4 squared, right? And therefore you could say k would be like 0. So now you can see that the vertex in this case would be negative 4, 0. But the whole point that I'm trying to bring to you is this is factorable. This is factorable into a binomial squared. So typically what we can do here is I'm actually going to create this, so therefore I can factor it. Now again, it's really important though that you understand, you just can't like add a 16 to a problem, right? So that's me explaining this is what I want. But again, this one doesn't have a 16, it has a 10 here, right? So what we're gonna do is we're gonna say, all right, I know x squared plus 8x plus 16 gives me a binomial squared, right? But I still have this 10 here. And then also, you just can't add a 16 to an equation, so therefore we're going to subtract a 16 on the outside of the equation. So again, when I add a 16 and subtract a 16, those undo each other, right? So if I took those away, I would have my original equation. But now, if I add and subtract on the same side, now all I'm doing is I'm just doing some magic with my grouping. I am going to group this perfect square trinomial because it is factorable into x plus 4 squared. And then 10 minus 6 is going to be a negative 6. And therefore, the vertex here is negative 4, negative 6. So not something that I really teach, that way, but hopefully for this live stream, that kind of gives you a little bit of idea. You could also use the a squared plus bx plus c. So therefore, b divided by 2 squared, and that's the number you add inside. But again, like if you already know what the perfect square trinomial is, like 8 divided by 2 is 4, 4 squared is 16. That's what you add and subtract inside of there anyway. So hopefully that kind of helped. It's a good method when you have something that is fairly basic for a perfect square trinomial. Obviously, once you start getting into like fractions or numbers that are a little bit more difficult, that might not be as straightforward. So therefore, that's why we a lot of times rely on the b divided by 2 squared. But hopefully, at least that helps for the majority of problems that you will be completing. All right, so for the next one here is 6x squared plus 3x plus 27, and the student asked me to solve, so I guess I should write an equation. So we're going to set this equal to 0. Now again, remember, if we're going to solve via the quadratic formula, we have to have ax squared plus bx plus c equal to 0. Just like if we're solving by factoring, we want to have the equation set equal to 0. Because again, when you factor, you want to apply the zero product property. You can only apply the zero product property, when you have a product equal to 0. So the same thing with the quadratic formula. You have to have a quadratic equal to 0 to apply that quadratic formula. And again, the quadratic formula is going to x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So in this case, what I'm going to do is just going to work through them. If you didn't have a calculator, then you could just be careful with doing the numbers. But for the sake of time, as well as making sure that I don't make any mental errors, I'm going to use a calculator. But let's go ahead and plug everything in first. So x, which represents the solutions, is going to be opposite of b, which is negative 3, plus or minus the square root of 3 squared, and I'll just write everything out, 3 squared minus 4 times a times c, all over 2 times a, which is 6. Okay, so the first thing I always like to do is determine the discriminant. And it looks like that's going to be a negative number, which it is. And so therefore, we know we're going to have some imaginary numbers, which I'll show you in just a second. But 3 squared is 9 minus 4. So let's see, negative 4 times 6 times 27. Ooh, geez. So 9 minus 6, 48. So that's going to be 639 square root. Jeez, I'm not familiar with that one, but yeah, it's not square. And I'm not sure of any square numbers that divide into that, nor do I want to play this game. 71 actually goes in there. So I just picked 9 because I saw it ended in a 9, and I took 639 divided by 9, and it goes in there 71 times. And 71 I am not aware of being divisible by any other square numbers, so therefore we're going to work with that. Sweet. Okay, but before we get to that, so I did 9, so what I did is I did 9, actually I'll just write out. So I do negative 3 plus or minus, this is 9, minus negative 6, or 6 times 4 times 28 gave me 648. So 648. And then this is going to be all divided by 12, okay? Now that gave me negative 3 plus or minus the square root of negative 639 divided by 12. All right, so remember, if we're taking the square root of a negative number, then that's going to give us our imaginary solutions, right? Or we could rewrite that using our imaginary unit. The square root of negative 1 is going to be I. However, I can break this down. So what I'll do is I'll just break this down over here. So this will be negative 3 plus or minus. That's not a plus or minus. Let's see here. Let's break this down into negative 1 times 9 times, what was that, 71? There we go, all over 12. Okay, so if you do negative 1 times 9 times 71, let's just double check my work. Negative 1 times 9 times 71 gives me negative 639. Perfect. So now what you can do is, again, the rules of radicals allows us to take the square root of each of those separately because they're separated by multiplication. So therefore I have negative 3 plus or minus, let's see, square root of negative 1 is I, square root of 9 is 3, so that'll be the 3I square root of 71. That's not a 1. Divided by 12, and then I can reduce all those 3 over 12s to be negative 1 over 4. So therefore I have a negative plus or minus I square root, negative 1, plus or minus I square root of 71 all over 4. So all I did was I just kind of divided 3 over 12 is 1/4, 3I over 12 is 1/4. So therefore there's a 1 there. I just got kind of divided out. But there you go, ladies and gentlemen. That's kind of the case by case we're there. And again, if you didn't have a calculator, you just want to work things out to the side from me on that. All right. Yeah, and I'm sorry, guys, for those of you that kind of added in, I have, I believe, 7 questions that I'm going to cover tonight. So, one thing, I looked at a lot of chat. So if those of you that did post on the chat or the community post, I will make sure that I, respond to each of your questions. And I apologize, I'm not going to be able to get to everybody's. And, hopefully that's a good thing that we're finally getting to the point where you guys are getting a lot of questions. So if I'm not going to be getting to your questions, which I kind of went through at the beginning of this live stream, then, please feel free just to kind of post any of these in the chat, and anybody that can really help you out, that would be excellent, because I'm only going to be able to really get to these questions. So I do apologize for those of you guys that maybe weren't able to put your question on the chat, but you have something that is coming up this week. Oh crap, I still got to do, you know what? I will be probably going live tomorrow. I don't want to say that, but I will. I think I'll probably, well, I'm going to go live at least one more time this week, because I got to go over our quiz in pre-calculus. So I'm not sure when. I'm going to leave that open. But if you're subscribed, then you will know when I go live. So make sure you subscribe, and you'll be notified when there. And I might be able to do an open Q&A. Kind of depends on my schedule at that time. But for right now, I will leave that open. I will let you guys know I will be doing, actually, I'm going to be doing 2 live streams actually this week. Yeah, because we have 2 quizzes and then we have a test next week. It's going to be getting busy. All right, crap. That's a busy week. All right, let's go and finish this up, because now my brain's like exploding. Like, oh my God, I'm like a student like you guys. Like, I have so many things going on right now. All right. So next one is write the equation of a line given m equals negative 2/3 through the point 2 comma negative 1. Now, there's a couple different ways you might see the slope-intercept form or point-slope form. The form that I like the best is y minus y1 equals m times x minus x1. Okay, where obviously m is going to equal the slope, and x1, y1 represents the point. Now, usually students get confused as saying, why is there an x1? What's the difference between x1 and x? And what's the difference between y1 and y? Well, again, remember, y and x represent any x and y. So it's kind of confusing, but if you think about, like, if you look at slope-intercept form, if I said y equals mx plus b, right? Well, again, x comma y, the x and y in that equation represent any x and y coordinate that lie on the graph, right? So that's the same thing here. Point-slope form, when we plug in a point and a slope, we're going to get it into slope-intercept form. But the thing is, so that's the x and the y. That's what represents any x and y that represent on the graph. The x1, y1 just represent one point that we are aware of, for instance, this point, that is on the graph. And m is, again, going to be your slope here and there. So really, all we need to do is when we're given a slope, or if we know the slope in a point, then we can just label this as x1, y1. I made up this problem, so the numbers might not be helpful, but we'll see. And now let's just go ahead and plug in the values. So we have y minus negative 1 equals a negative 2/3 times x minus x1, which is 2. And it doesn't look like everything's going to be pretty. So either way, that is what it is. So therefore, this becomes y plus 1 equals, let's go ahead and distribute this. Well, actually, that is the equation of the line anyway, so you're kind of done at this point. But in calculus, we just leave it like that. That is an equation of line, just in point-slope form. But if maybe your teacher is asking for slope-intercept, so let's just go ahead and do a little magic with some fractions. You could distribute over here. That'd be a positive 4/3. All right. Now, so if I wanted to go ahead and figure out what this would be in slope-intercept form, so I could find the y-intercept, for instance. I'll just subtract a 1. And actually, this isn't that bad. So it'd be y equals negative 2/3 x. Instead of subtracting 1 from 4/3, I could just say, well, isn't 1 the same thing as 3/3? And therefore, my final equation is negative 2/3. And the answer to that was yes. So therefore, that's going to be plus 1/3. And there you go. So therefore, I took the point and the slope, I put in the point slope form, and therefore you can just plug them in and then I simplify. And you could also do this using only slope intercept form, but I think it's, I'm not sure if one way is the other. Some problems it's a kind of a toss up, and some ways some problems are definitely a little bit easier than others. All right, for the next one, solving exponential equations. So I kind of made up these problems, so I'm hoping that my problems are going to they work out. There's also a couple things that I do not recall from at least the Algebra 2, or at least when I taught these. So I'm just going to try to remember as far as some of the common elements that I want students to know. So, all right, first of all, if I have x to the a over b, that is equivalent to the b root of x to the a. So that's like the general idea of a rational power. So when you have a variable raised to a rational power, then that is basically whatever the denominator is, that's like the index of our root. And then at the numerator is representing like the power of that variable. All right. So that's one rule there. The other rule I think is important to kind of remember is is the power rule of exponents. So remember, if you have x to the m times n, you can rewrite that as x to the m times n, right? So if you have a variable, or if you have an exponent raised to a power, then you just multiply those powers. So there's a couple different reasons why I think that is. Oh, and I guess one last thing is, just this multiplicative inverse, I guess. So remember, if I had like a times 1 over a, right? That's just equal to 1, right? That's that multiplicative inverse that we have here. So, and I guess one more thing is, I keep on really going through there, because that's the big case that we have here, is remember when you take the square root of a number, like when I say, what is the square root of 4? Or let me do it this way. Like if I had x squared, if I had x squared equals 4, okay? Now typically, in Algebra 1, Algebra 2, in pre-calculus, like if I had this, basically I'm going to take the square root to both sides. But remember, when we introduce the square root, then remember, the square root, you have the positive or the negative, right? These solutions that make this true is going to be plus or minus 2. Now, another way we could look at this is say, well, if I want to get this x to be 2, to go from 2 to 1, I could also just raise this to the 1/2 power, right? So therefore, that's really 4 to the 1/2 power. Now again, doing everything we already know about rational powers, that is exactly the same idea here. Oh, okay, so now I'm taking this square root, so therefore x is going to equal plus or minus 2. So it's really that idea is when you see a even number in the denominator, you got to think that's the even root. You have to include you have to make sure that you are including the positive as well as the negative. Now, some people might think of, in this, like, oh, we have the even root. Well, again, be careful. It's what you're doing to solve for it. So here I have 3/2. Now, again, if I wanted to solve for this, if I wanted to get rid of this power, right? If I want to solve for x, I want to get rid of that. So what I can do is just take the reciprocal here, which is going to be a 2/3. All right, so therefore, those using the power rule as well as this multiplicative inverse, this is just going to simplify to x minus 5 equals, now you would say, typically this is going to be 8 to the 2/3, which is really the cube root. So 8 to the 2/3 is equal to the cube root of 8 squared. So some people might be aware of this, some people not. And typically, what we practice ahead of time of this is simplifying numbers. So really what I want to do is, can I rewrite 8 to the power of 3? And again, you can. 2 to the power of 3 times 2/3. Well, now you can see those 3's are going to divide out, right? Because that's really a 3/1 times a 2/3. So now you multiply them. And therefore, I get x minus 5 is equal to 2 squared, which is 4. So therefore, x is going to equal 9. And you can see how there's that one solution and how that works out. So that is when you have an exponent that is isolated. In this case, we can't really do that because my exponent's not isolated. So what I'm going to do is I need to isolate it. So I'm going to add a 4 to both sides. I get 4x to the 2/3 equals 16. Divide by 4, divide by 4. X to, what happened? So x to 2/3 is equal to 4. All right, well now I can undo raising x to the 2/3. But when I do it, just like I did over here, you can see now I'm basically taking the square root of something cubed, right? You're cubing something squared. So this is very important now because if we look at this, what we basically are doing again is taking that square root. So therefore we have to include the plus or minus. And again, sorry, should I do this like this? So another way you could look at this, again, if this is confusing, so hopefully most students understand this one, but they get confused in this plus or minus. So what I recommend is take the problem like this and then rewrite it using the power rule. So like kind of decompose that power rule. So we could write it as 4 to the 1/2 raised to the 3rd. Now again, 4 to the 1/2 is really like the square root of 4, which x is going to equal plus or minus 2 cubed. Okay, so therefore we're actually going to have two answers. X equals positive 2 cubed, which is 8, or x equals negative 2 cubed, which is a negative 8. And then all we want to do is, we could always go ahead and plug them in and make sure that they would go ahead and work for both of those. And you can see that actually when we do those, they would work because when you take when you would square both of them and then cube them, you're going to get 4 for each of those when you plug both of those in. So they both do work, but hopefully you can kind of see that operation. So that's just two examples. The student did give me any examples to go off of. So hopefully that has helped some of you guys out. All right, so now let's get into some geometry. It's been a while since I did some geometry, so I'm very excited to kind of at least do one of these. They also needed some proofs ones, but you can see we're kind of already at our time. And I do apologize for those of you guys that have kind of joined in, but I will stay a little bit longer, get into the chat, and maybe if you guys have like some easy questions, some questions maybe I can address like rather quickly, I'll be able to do that. And if you've posted a question in the community post, I'll make sure I get to those questions as well. But I will stay after a little bit, hopefully, depending. I don't think these two questions should take too long. What's this other one? Yeah, okay. Should be long. Should be too bad. All right, so the next one says, find the point D of the parallelogram given A, B, and C. And actually, I forgot to copy down the student's point. So I just wanted to make sure I did like plot them just real quick just before I wrote them down. And I wanted to make sure that just in case there wasn't anything I didn't like miss. So first thing, what I tell students when I taught geometry is just plot the points. So we have over 1, up 5. 1, 2, 3, 4, 5. And then label the points. 3. So 1, 2, 3, 1, 2, 3. And then we have C, which is over 2, down 1. Okay, so there's something very important about understanding for the parallelogram. And, I think when you're getting to this point for geometry, you just got to remember the characteristics, like what makes each of these, true. And again, when we're doing these, there's really kind of two things you're looking at. You're looking at, measurement, like the lengths of the sides, and then the slope. So really, if, you can prove certain shapes or certain shape based on like given points, based on really finding the length using the distance formula, as well as using the slope. And obviously one thing we know about a parallelogram is that the sides are going to be have equal slopes. So even though I'm not going to be doing a proof, but that's one thing I'd want to look at is them having equal, opposing sides having equal slopes, as well as, or actually as long as both pairs have equal slopes, then they're going to have equal measurements as well. Now in this one, what I'm going to look at is, I guess maybe, I can't remember what the question was, to prove that it's a parallelogram or assuming that it's a parallelogram. So if I know C, I can imagine C is going to be, or D, I'm sorry, is going to be somewhere over in here, right? So a couple different ways you can do this is I can just look at what is the relationship here from C to B. Well, it looks like it's over 1, up 1, 2, 3, 4. Okay? So then to go from A to D, I could go down 4. So 1, 2, 3, 4 to the left 1. And my graph is not going to be perfect, but I could always go ahead and confirm it. Like from A to B, that's down 1, 2 over 1, 2. And then this one is down 2 over 2. And it looks like it's going to work out, and that will produce now a parallelogram where I have opposing sides are parallel. Okay, for last question, or at least formal question, and again, guys, I'll get to you guys any kind of math questions or general questions you guys have. So this one says P of x is divided by x minus 2, and Q of x is the quotient with a remainder of -1. Find P of x. Okay, so we need to understand how to write a division problem when we have a remainder. All right, so if I have P of x divided by x minus 2, and it's given me a quotient, which we're going to call Q of x, which ends up being 2x squared plus x minus 2, then all we do is to find the remainder. If you recall from long division or synthetic division, when you have a remainder, you basically take the remainder and then divide it by the divisor, which is x minus 2. So really what this question is saying, we already have everything. Now we just need to solve for P of x. So all I need to do is, really just multiply by x minus 2 on both sides. Now we can't be crazy here, because make sure to put this in parentheses. So therefore, oh no, crap, I got 2 more questions. So now P of x is going to be here, and then here, they're going to divide out, right? So therefore, all I'm really looking for now is 2x squared plus x minus 2 times x minus 2, and then plus a -1, right? Or just -1. So plus a -1 or just -1. So now, really, all you got to do is just multiply a trinomial times a binomial and then subtract 1. So let's go ahead and just do FOIL. We could use the box method, but just to kind of keep things simple, I'm just going to use FOIL. Actually, you know what? I'm going to do this. I'm going to do it twice. Okay, so x times 2x squared is going to be 2x cubed. X times x is going to be an x squared. X times -2 is a -2x. Then -2 times 2x squared is going to be a -4x squared. -2 times x is going to be a -2x. -2 times -2 is a +4. And then I have a -1. All right, so now let's just go ahead and combine like terms. So we have a 2x cubed, which is going to be my highest power. We have an x squared and a -4x squared, so it's going to be a -3x squared. Then we have a -2x and minus a 2x, so you owe me $2 and you borrow $2 more, so that's going to be a -4x. And then we have +4 minus 1. And there you go, ladies and gentlemen. That is our P of x. All right, so the last problem, the student asked me to kind of go through, and actually I forgot to do this. That was my fault, so I do appreciate, even though I'm not sure if it was the same student that was acting as Brian McLogan. But either way, some student did ask me to go over graphing of sine. So really kind of 2 things I want my students to understand. First, the initial period. So the initial period of sine, which is basically like 1 revolution around the inner circle, looks like this. Goes up to 1, goes down to -1, has 2 pi, crosses that pi. Let's see, pi halves, and then this would be 3 pi halves. So the graph goes up, crosses, down, up. Okay. So there is what we call the initial period. Now, based on the transformations, I'm not going to write them all out, but when we have transformations for the sine graph, we have basically A, B, C, and D. And this is something that goes all the way back to when we did transformations of any function, right? It doesn't matter what our function is. A times B x minus C plus D. So this is something that we covered in transformations of functions as well, if you remember the 12 basic functions. So A, if you remember from our functions, A was a vertical stretch or compression, which that happens with sine too, but what that actually does for sine is what it does, it changes what we call the amplitude, basically how high the graph is going to go from up to down, regardless, not including any vertical shifting. B was, and also it reflects about the y-axis. A reflects about the x-axis. Okay, so a vertical stretch and compression as well as a reflection about the x-axis. Where B was a horizontal stretch or compression and a reflection about the y-axis. Well, for the sine graph, it's going to be the same thing, but we don't really talk about it as a horizontal stretch or compression. We talk about that in terms of its period, basically how long it takes the graph to repeat itself. You can see in the initial period, the graph takes 2 pi for it to repeat itself. So obviously if there's a compression, it's going to be a little bit shorter. And if there is a horizontal stretch, it's going to take longer. And then C is going to be your horizontal shift, basically shifting the graph left or right. And that is the same thing with sine, and D is your vertical shift, shifting basically graph up or down. And that doesn't matter with sine as well. We call them really the same kind of things. The really only kind of change here is the trigonometric functions. You know, again, like those formulas, the idea of amplitude and period is kind of new. But remember, when you're identifying the phase or the shift, actually we call the shift the phase shift for sine and cosine, or at least for sine in this case, because we're not doing cosine. But when we're talking about the C, remember we have to factor out B. So you can see in both these equations I have a B in there. Obviously I'm not covering one with a B, but just make sure you have that factored out in before you do that. Okay, so let's go ahead and let's get on to the questions. So when I have this 3 here, we got to say, like, what is that 3? Like, so what is the only thing that's being impacted here if I needed to graph this? So really, this is going to be what we call the amplitude. So the amplitude is absolute value of A, which in this case is absolute value of 3, which is just 3. So basically what that tells us now is this graph, instead of going up to 1 and down to -1, is going to go up to 3 and down to -3. So everything else is going to remain the same. So I'm not going to go through sketching everything back again because everything is exactly the same. The only difference is now the graph goes as high as 3 and down to -3. And again, that can change based on the shifting left and right. The next one is, what about when we have a 2x? Well, what's going to be impacted in that case is what we call the period. And the period is 2 pi divided by the absolute value of B, which B in this case is what's being multiplied by x, which is 2. So therefore that's 2 pi divided by 2, which is pi. Okay? So now the graph goes up to 1, down to -1, right? Because the amplitude is 1, right? So it's going to go up to 1, down to -1. But if I was going to call like here pi, you can see the graph is being compressed, right? If I was going to try to be a little, try to make it to scale based on those other graphs, you can see how everything is being compressed a little bit more. And then the last one is going to, so you can see the amplitude is 1 and the period is going to be 2 pi. The difference here is we have a shift of pi halves to the right. Remember, when it's x minus pi halves, you're going to be shifting pi halves to the right, as well as a shifting up 1 unit. So basically, when we did, I don't really work on graphing these, but I'll show you at least what I used to teach. When we do have a transformation, a B and a C, what I did is I changed the initial, start, and then as well as end. So if you look at the initial period, you can see that it starts at 0 and it ends at 2 pi, right? And that's already there. So all we're going to do is take whatever's inside of our function, in this case x minus pi halves, and set that equal to 0. So you see the graph starts at pi halves, and then we take the end, which is 2 pi, so x minus pi halves equals 2 pi. And therefore x equals, now again, we could write that as 5 pi halves, right? Because 2 pi is 4 pi over 2. And therefore you add 1 more pi, that'd be 5 pi halves. So now if I was going to do a graph here, right? The amplitude is from -1 to 1, but the graph got shifted up 1, right? So now the graph's going to go up to 1 and 2. instead of it starting at 0, I'm just going to call this now at pi halves and this at 5 pi halves. And again, I'm not doing an excellent job here of graphing just because, oops, no, I'm sorry. This actually goes to there. Graph got shifted up 1, right? So it starts there, goes up there, down to there, and there. So basically that horizontal line that cuts the graph got shifted up 1. So the graph would look something like that. Okay. Now, obviously, guys, graphing is something that takes a little bit more time and a little bit more detail, but for the purpose of the live stream, hopefully at least these 3 examples helped you out. I am now tired, 40 minutes of math, and I got more to do. But for those of you that are still into the chat, welcome. Thank you so much. Jessica, Wendigo, Adeline still here, Roof, TNS, thank you guys. I do appreciate you guys joining in. I really hope you guys, a lot of this chat is helping you guys out. I got a question. Oh. Cool. All right. Is tangent negative? How's that graph? All right. Well, guys, I will stay for a couple more minutes. If there's any maybe easy questions, not so much easier, but like easy or quick questions, I'll be more than happy to address those for those of you guys that hung with me so long. John Day said, good. Thank you, John. Ajay asked how to graph those. Well, thank you very much. Well, hopefully that helped. My next live, I plan on going live, guys, every Sunday on 9 p.m. Eastern. So, and then for those of you that have questions that maybe didn't get your questions answered, I would recommend that you guys, I've been trying to get everything scheduled. And excuse me, I'm getting tired. I'm trying to get everything scheduled on Saturday. So I usually do my post on Saturday. So just make sure that you ask her a question on the updated community post. I saw a lot of you guys have added questions on the old post, which I didn't check prior to this live stream. So I do apologize to that. I will make sure I go into that last week's post and respond to all of the questions. If I have an answer or not, or if I can at least lead you in the right direction, I'll go ahead and do that. So just make sure you stay updated on the post for you guys. Can I explain dilations? I'm not really sure. It's just been a while. I haven't taught geometry in a while, so I'm not really sure, like off the top, what would be the best way for me to approach giving you a quick explanation of dilations. The best thing dilations is basically like, remember, it's a scale factor. You're multiplying by a, fraction, either larger than 1 or less than 1. And basically that's just going to be stretching and compressing, kind of like what we did here. That's really what dilations are here. We took this graph and we vertically stretched it. Here we horizontally compressed it. So the only difference with dilations, typically at least in the geometry format, is you're applying that, stretch or compression to every single one of these points, which again, I didn't actually find the point. D is 0, 1. So when you're stretching or compressing, you're just applying that to all the points, right? So that's basically maybe an explanation of dilation, so that I can help. All right. Done. When you're in kindergarten. Well, awesome. Great for you. All right, my exam is next Monday. Any advice, Mr. McLogan? The best advice I can give you, at least on this short amount of time, is just to, one, do as much studying. When is it, next Monday? Yeah, do as much studying now. And therefore, because you want to do as many practice problems as you can, like as many practice problems as you do. So do a lot of practice problems this week. Therefore, for like Friday, Saturday, and Sunday, you should just be reviewing your notes, just kind of doing a quick little review of the notes. Again, I tell my students to create a cheat sheet, basically like a summary of all the topics, because for Friday, Saturday, and Sunday, that's what I expect you just to do. It's just kind of review, the common things that you're going to want to remember. And the main thing is, I think, just making sure you do a lot of that practice and not trying to cram that information. And I'm assuming if you have one exam, you're going to have multiple exams. So it's just kind of like that juggling of, doing the best you can do with the circumstances you have. I know a lot of you guys have a lot of things going on, especially with multiple classes and stuff like that. So try not to, be over intimidated when you do take the quiz. Just make sure you do all the problems you know how to do first. Don't spend 20 minutes doing one problem if you haven't answered all the questions yet. So, just kind of give you some quick advice there. All right. What if the period of cosine is equal to 1? Well, then you'd have a compression. I'm not really sure what the question. You could have the period equal to 1. Then you're just going to have a compression. Stephen Lee, thank you very much. I'm glad to have you on there. Thank you. Jose says, do you play any sports when you were younger? Yes, I did play sports when I was in high school. Basically, my whole life I played sports. But for high school, I played football, wrestling, and baseball. And then when I got out of high school in college, I started playing rugby. And I played rugby for just around 8 to 10 years. And then now I just kind of work out as I can. But my body is pretty banged up from all the sports and playing basically my whole life from on there. So not as agile as I can. So I got another question for the point slope form. And again, write the equation in slope intercept form of the line that passes through the point. Of the line that passes through the point. Yeah, so I have an equation very similar that I previously explained. So I'll just go ahead and check on with that for on those problems because I don't want to do another one of those. But it is a little bit past, yeah, back in the day when I had a little bit more back. Now my back, my shoulders, my legs, everything is sore and everything like that. So, but I still try to stay active. And that's one thing that's, if I don't, then I just tense up and it's horrible. So not tighten up, but tighten up. All right. All right, guys, I am going to sign off for the night, but I will be going live again for you guys next week. So thank you so much. I do say, was math invented or discovered? That is a good question for a good debate, which I don't have time for now. Man, I see you guys just adding in there. Jeez. Thank you so much. I'm not going to be able to do any more questions, but I am kind of thinking, yes, I would like to get into statistics, but it's probably not going to happen while I'm still a teacher. So we'll just kind of see. For that, I do not play Fortnite. I went to Western Michigan University. Yes. Yeah, sorry, guys. I'm not going to be able to do... Ooh, that's a good expansion. Dang. Yeah, I'm not going to be able to do that. At least now I'm tired. I'm over my stream. I've been going for 48 minutes, so I think it's time for me to sign off for you guys. I do appreciate it. Thank you so much, guys, for staying with me for the end of the stream. It is time to go. I will see you guys next week. Hope you guys have a great week, and I'll see you next stream. Cheers. Oh, wait, that doesn't... No. Man, I wish this did work. It doesn't work. All right.